Today I will be discussing about a design example on the gusset base. So, in last lecture we have discussed the design procedure of the gusset base, and which includes the determination of the gusset plate dimensions and the base plate dimensions and the number of bolts. So, how to find out step by step, that will be clear if we go through this example. So, quickly I will start this example. The example is this, that a column section of ISHB 350 at 710.2 Newton per meter carries a factor axial compressive load of 1700 kilonewton and factor bending moment of 85 kilonewton meter. Now, the design the base plate and its connection. Assume concrete pedestal of M20 grade. So, here you remember ISHB 350 has two type of different weight. So, here we have taken ISHB 350 at 710.2, because with different weight its dimension are slightly different. So, keep it mind this, that we are going to consider ISHB 350 at 710.2 Newton meter, and the compressive load is 1700 kilonewton, and also we have added here one moment, that is 85 kilonewton meter. So, through this example also we will see how to take care of the moment. That means, if moment are also acting on the column, then how the base plate will be decided. That means, the thickness of the base plate and its other dimensions, how it will be decided, that will be see through this demonstrated example. Okay. So, if we go to the solution, then first we need to note down certain properties which will be required for the calculations. Like for Fe 410 grade of steel, we know these are the properties, and for M20 grade of concrete which is been used here. So, the bearing strength of concrete will be 0.45 FCK into 0.45 FCK, which will be 9 Newton per millimeter square, right. And also partial safety factor is 1.1 gamma m0 and gamma mb for bolt, as we are using bolt. So, 1.25. Here we will be using bolt connection to demonstrate how the number of bolts are decided. Then here thickness of the flange, thickness of the wave which will be required, we have noted down, whole depth of the section, means overall depth, then cross sectional area. Also we need to know the ZE, that also will be noted, we will be noting. Then here design compressive load was given as 1700 kilonewton and bending moment was given 85 kilonewton meter. So, here eccentricity will come, and that amount of eccentricity will be 50 millimeter m by p, because we need to know whether eccentricity is less than L by 3, L by 6, or in between L by 3 to L by 6, or greater than L by 6. Okay. So, that we need to know. Accordingly, the pressure will be calculated. Pressure means bearing pressure from the concrete. So, as moment is there, so here simply the pressure will not be the P by A. We need to find out the pressure from moment as well. So, this also we will see here. So, now here you see that if we use 16 mm gusset plate, because minimum thickness of gusset plate will be 16 mm. So, in each side we are going to provide 16 mm gusset plate, and we are assuming two cleat angle or gusset angle as ISA 200 by 150 by 15, and I told earlier that we should provide unequal section with larger length as vertically placed. If it is so, then we can hold the number of bolts properly. So, to do that we are providing a larger section of angle, and here you see the thickness of angle also we have considered 15 mm, which is approximately equal to the gusset plate thickness, because both the thickness should be more or less equal. That is what we have told earlier. Now, here E by L is coming. E we calculated as m by p as 50. So, E by L we are going to get 1 by 11, assuming that L as 550. Remember, here we are assuming a certain base plate length, because we do not know the base plate length, and as we do not know the base plate length, we cannot find out E by L unless we assume certain base plate length. So, to start with, we have started with some assumption, that is length of the base plate. Okay. So, if we consider the length of base plate, then E by L will become 1 by 11, and that is less than 1 by 6. Okay. So, if it is less than 1 by 6, then I can find out the pressure diagram as like this. Because in case of L by 6, the entire section will be under compression. Okay. So, here the maximum pressure we have to find out. If this is F, we know this will be P by L B into 1 plus 6 E by L, right, and this is P by L B into 1 minus 6 E by L, right. So, if we consider the maximum one, then it will be 1 plus 1 2. So, that will be 2 P by L B, right. So, F will be 2 P by L B. So, the stress, maximum stress developed at this will be 2 P by L B, and it should not be greater than 0.45 FCK bearing strength of concrete. So, if we make equal to the bearing strength of concrete, then we can find out the value of B from here, right. So, B will be, I can find out as 2 P by L into 0.45 FCK, right. So, if we put those value, we can find out approximate value of B, that is B as 2 into P was considered 1700 into 10 cube, and then length was assumed as 550 and 0.45 FCK was 20, right. So, this is becoming 687 millimeter. So, we can provide B as 690 millimeter, right. So, the dimension of the base plate in one direction we can provide 690 millimeter. Okay. Then we will find out the projection, right. So, to find out projection, if we draw the diagram, say this is the column. Now, it has an angle, gusset plate, this is the gusset plate and this is an angle, and this is the base plate. So, this base plate length is 690. So, now this projection we can find out. Okay. So, if projection, if I write P or projection length say LP, then LP I can find out as 690 minus 350 is the depth of the section plus 2 into 16 the gusset plate thickness plus 2 into 150 the length of the horizontal angle, Okay. The horizontal arm of the length angle is 150. This is then divide by 2, this is 4 millimeter. Okay. So, projection length we are providing 4 millimeter. So, now let us provide the base plate size as provide L by B as say 690 by 550, right. So, area provided we can find out, that will be 690 by 550, this will be the total area, that is 379.5 into 10 cube millimeter square, and Z E, the elastic section modulus Z E I can find out, that is 550 B d square by 6. So, B t square by 6 will be this, right. So, this will be 43.64 into 10 to the power 6 millimeter cube. So, once we get the value of area of the base plate and the section modulus, then I can find out the maximum stress of the section, that will be P by A plus M by Z D. So, P was 1700 kilonewton, area we calculate as 379.5, right. M is 85 kilonewton meter by Z is 43.64. Okay. So, maximum stress developed is coming 6.43 and bearing pressure of the concrete was 9 mm. So, it is okay. So, the maximum stress maximum pressure in the base plate from the concrete pedestal is becoming 6.43, which is less than 9 Newton per millimeter square. So, it is okay. So, this is how we could find out the maximum pressure. Now, I can find out the minimum pressure, F min. So, minimum pressure will be P by A minus M by Z D. So, it will be 379.5 into 10 to the 3 minus 85 into 10 to the 6 by 43.64 into 10 to the 6. So, this will be the minimum pressure, which is coming 2.53 Newton per millimeter square, right. So, now let us draw the diagram, pressure diagram, because we have to find out the maximum moment developed at the critical section. So, if we draw the diagram, we can see this is a column and then we have a gusset plate, then an angle, right. Similarly, here we have a gusset plate and then angle, right, and then some overhang portion. Okay. So, now we have total distance, we know the total distance and we can find out the critical distance, right. So, critical distance will be, this if we calculate, we will see this will be 139 millimeter and rest will be 551, right. And the pressure distribution if we see, it will be, if moment is in this direction, then it will be like this, right. So, pressure will be like this, where the minimum will be 2.53, maximum will be 6.43, and we need to know this. So, we need to know the pressure is this trapezoidal distribution, and we need to know the moment at this critical section. Okay. So, moment at this critical section we can find out. So, to know the moment at critical section, we have to know the pressure here. So, by linear interpolation we can find out the pressure at this section. Say this is section x x, if we say, then the moment at this critical section I can find out, say m x. Okay, no, first pressure I have to find out, say p x is equal to 2.53, because I can make like this, and then the linear interpolation of this. Okay, this. So, 2.53 plus 6.43 minus 2.53 into 551 by 690, totally 690, this is 690, right. So, from this I can find out pressure at critical section x x as 5.64. Okay. So, this is 5.64. So, moment at that section I can now find out. So, moment will be 5.64 W L square by 2. So, 5.64 into L is 139 square by 2, that is for this uniform distributed load, plus the linear varying load, plus that will be half into 139 into 6.43 minus 5.64 into 2 by 3 of 139, right. So, this will be 59573.1 Newton millimeter. So, moment at critical section we could find out as this. Remember, if only axial load is there, then simply we can find out m is equal to W into c square by 2, and we can find out the thickness of the base plate as we have calculated earlier. Means in the earlier lecture one equation we have shown from which we can do, but here as moment is there we have to derive that things. So, moment once we know, we can also find out the moment carrying capacity m d, which is 1.2 into f y by gamma m 0 into z d, right. So, that will be 1.2 into 250 by 1.1 into z is 1 by 6 b t square. So, b is 1 into t is say thickness of the plate, base plate and angle. So, total thickness is T A, aggregate thickness. Okay. So, T square, this is coming 45.45 T square. So, the design bending strength of the section in terms of its aggregate thickness is 45.45 T square Newton millimeter, which need to be equal to the moment at critical section, which was coming 59573.1. So, by equating these two, I can find out the value of T A as 36.2 millimeter, which is called aggregate thickness of base plate and cleat angle. So, the thickness of base plate and cleat angle is this. Now, I can find out thickness of base plate, say T B as aggregate thickness minus thickness of the angle, angle thickness was considered as 15. So, this is coming 21.2 mm. So, we can provide 22 mm, right, and this is greater than the TF, thickness of the compression flange, which is 11.6. So, the thickness of the base plate can be decided as 22 mm. That means, now the base plate dimensions are fixed 690, 550 and 22. Now, you see somebody can design in different way. We have considered certain length and that on that basis we have considered other values. Now, one can consider length as different, say in place of 550 somebody can consider say 600 or 500, then also they can find out the other dimensions. So, as per the designer's choice, he or she can choose a certain dimension and accordingly he can find out the final dimension. Now, we will be go to the connection, and here we are providing bolted connection. Okay. So, bolted connections if we consider, now we have to consider whether it is means what is the bolt value. So, bolt in single shear, because this will be in single shear, will be calculated, say VDPP. So, that we know ANB into FUB by root 3 by gamma MB, right. Now, if we use say for example 24 mm diameter bolt, 24 mm diameter of bolt of grade 4.6, assuming 24 mm diameter of bolt, I can find out the value. Okay. So, that will be 0.78 into pi by 4 into 24 square by gamma MB into FU by root 3, FUB is 400 by root 3. So, this is coming 65.2 kilonewton, right. So, the shearing strength of bolt is decided. Now, we have to also find out the bearing strength of bolt. So, for 25 mm diameter bolt, a 24 mm diameter bolt, edge distance will be 1.5 into D0, D0 is 24 plus 2. So, that is coming 39, we can use as 40 and pitch will be 2.5 D. Okay. So, this we can use as say 65. So, pitch we are providing 65 and edge we are providing 40. So, from that we can find out the KB. KB will be smaller of E by 3 D0, which will be 0.51, P by 3 D0 minus 0.25, which will be 0.58, and FUB by FU, which will be 0.98 and 1. So, smaller of this 4 will be 0.51. So, the value of KB we can find out on the basis of edge and pitch, whatever we have assumed. So, bearing strength VPDB, bearing strength of bolt will be 2.5 KB into D into T. T is the thickness of the smaller one, that is TF here 11.6, because one is we have considered 16, another is 11.6. So, smaller one is 11.6 into FU by gamma. So, if we consider this, then we can find out this value as 16 kilonewton. So, the bolt value will be the lesser of these two, means 116 and earlier we got 65.2. So, the strength of bolt value means strength of bolt will be 65.2 kilonewton. So, once we know the strength of bolt, we can find out the number of bolt. Okay. Number of bolt will be P by bolt value. Now, what is this P? We can assume the column end and gusset material to have complete bearing. If we assume complete bearing, then 50% of P will be transferred through bearing and 50% will be transferred through bolt connection to the gusset plate and to the base plate, right. So, depending on the assumptions, means how the connection has been made, whether it is complete bearing or not, depending on that the force will be calculated for calculating the number of bolt. So, if we assume the gusset material to have complete bearing, then 50% of the load will be assumed to pass directly and 50% of the load will be passing through the connections. So, if it is so, then I can find out that 50% if we assume to pass through the connection, then 0.5 into 1700 by bolt value. So, this is becoming 13.03, that means we need to provide 16 number of bolts. Okay. So, if we provide 16 number of bolts, then in each side we will provide 8 number of bolts. Okay. So, 8 number of bolts in each flange will be provided, and if we provide in 2 rows, then 4 numbers of bolt in each row will be provided, having 2 rows of bolt, right. Now, I will show the diagram later. Now, before that I have to find out the dimension of the gusset plate. Dimension of gusset plate. Okay. So, here height of the gusset plate will be, the height of the angle was 200 plus, see if we have gusset plate this and if we have column like this and if we have angle like this, then the angle height was 200. So, 200 plus we have 2 rows of bolt. So, here 1 row of bolt, another row of bolt. So, to accommodate that we need to find out the distance, that will be pitch distance plus 2 into edge distance. That means, this is plus 65 plus 2 into 40. So, height of the gusset plate at least has to be 345, right, height of the gusset plate, and length of the gusset plate we can assume as the length of the base plate. So, if we assume length of the gusset plate as length of base plate, then length will be 550, because length of the gusset plate was considered 550 parallel to the wave, parallel to the flange, right. So, we can provide gusset plate dimension as 550 by 345 by 16. So, this will be the size, and 16 numbers of 24 diameter of bolt has to be provided. So, finally, we can draw the diagram. So, gusseted base with bolt connections we draw. I am drawing just the side view, because we do not have much time. So, if it is so, it will be like this, then this is the angle thickness and this is the base plate, right, and this dimensions will be 550 and let us provide the number of bolts. So, bolt will be provided total 8 in each direction. So, 8 into 8 16. Okay. Similarly, to hold the members in other direction, we are providing here few bolts, and this will be the gusset plate, and this is the angle ISA 200 by 150 by 15. Okay. This is flange with 250, all are in millimeter. So, this is gusseted base with bolted connections, right. But in case of welded connection, calculations will be different. So, in that case you will see the thickness of the base plate will be little higher, because here thickness of the base plate is calculated considering the thickness of the angle as well, right. So, this is how one can design a gusset plate when the column is under compression and moment. Okay. So, this is all about the today's lecture, and before going to finish this entire lecture, I would like to suggest one thing, that please go through the IS code 800 2007, IS 800 2007. This is not a mathematical course or some structural analysis course that everything you will be understanding through logic. Here logic is definitely there, but numerous numerical equations are there, expressions are there, which is derived from some experimental observations, like some coefficients are got obtained from experimental observations, right. So, and those are given in tabulated form, which we need to remember few of them, or we have to go through that code and then we can find out. So, when you will be going through my lecture, I would suggest you take a code and try to follow that code with this lecture, then it will be easier, and you do not have to remember all the expressions. Many big expressions are given, where many numerical expressions means are given, which is difficult to remember, its coefficients are difficult to remember. So, those things you can follow from the code. Okay. So, whenever you will go through the lecture, please sit with the code as well and revise the things along with code, and try to find out in which page or at which clause these Codal provisions are there, so that you can remember. Right. And through this lecture you will not understand everything unless you go through some workout example. Okay. And if you go through workout example, then it will be clear, and when you will be going through workout example, please refer the code, so that how the coefficients are obtaining, how the equations you are going to get, that you can find out, and accordingly you can design the things. So, through this lecture, means the entire lecture, means I hope that you will get a concept of design of limit state method for steel structure. So, how to design a steel member using limit state method, that concepts I hope it will be clear. However, it will be much clear if you work out some example, then the concept will be much clear. I thank for your patience, and I hope you will enjoy this lecture. Thank you.